We already did this first one. This first one was a triangle question. You can recognize it's a triangle question if you're given a trig ratio and you're told something that'll help you figure out what quadrant. Just a reminder, we knew this one was in quadrant 4. And then you can label the sides. The adjacent side would be 3. Hypotenuse would be 8. A squared plus b squared equals c squared. This was root 55. And then just using the triangle, you can calculate sine is opposite over hypotenuse, and tan is, ooh, good save. No, that's not a good save. I tried to save it, but it failed miserably. This tan is opposite over adjacent, and they'll both be negative because they're in quadrant 4. So what happens in this unit is you learn a couple of things. We now know what a radian is. We know 3 big ideas, that points on the unit circle are cos, comma, sine, that sine squared plus cos squared equals 1, and that tan is equal to sine over cos. And this unit at the beginning seems difficult because with just a few little ideas, the number of questions that we are now able to do is huge. So we can get questions that look like this. Is that point on the unit circle? Well, at first you'll say, no, that's not one of the ones I memorized. But if you look at a circle, did you memorize every single possible point that could be on that circle? No. So there might be other points that are on that circle. How would you know whether or not this one was? Well, you could use 2 of your big ideas for this one. You could say, well, I know that if it's on the unit circle, this is cos theta and this is sine theta. If it's on the unit circle. And if that's cos theta and that's sine theta and it's on the unit circle, I know that sine squared plus cos squared theta equals 1. And so we just need to check if I square sine and I square cosine, what does that equal? Now, I'm not going to make it equal to 1 yet, because that's what I want to check. But now if I square these, root 6 squared is 6, 3 squared is 9, plus 3 over 9 equals 9 over 9 equals 1. And we can make a statement. If this point is on the unit circle, in quadrant 3, find y. And sometimes you're going to get options. Like this one, you have a couple of different options on how you solve it. You could use the sine squared plus cos squared equals 1. I, however, find whenever you can draw a triangle, that tends to make the question even easier. So if I draw an angle in quadrant 3, and make a right angle triangle back to the x-axis, label my reference angle. Based on that reference angle, cos is 12 over 13. That means your adjacent side could be labeled as 12. Your hypotenuse could be labeled as 13. Yes? That's right. I'm not putting the negative on there because I'm just measuring a distance. And then when I find my y-coordinate, can you see that your y-coordinate in this quadrant has to be negative? And your y-coordinate is sine, and sine is negative in quadrant 3. A squared plus b squared equals c squared. Maybe you recognize this one. Obviously, my triangle is not drawn to scale. 169 minus 144 is 25. And so we know that sine of theta is going to be negative 5 over 13. So our y-coordinate is equal to negative 5 over 13. And this year, because we're not restricted just to 0 to 360 degrees, now we have to figure out if you have a large angle in degrees like 4,300 degrees, what quadrant does that end in? What is a coterminal with? So here it says, given the angle of 4,300, find which quadrant it's equal in and state the first positive angle coterminal with theta. So if I take 40,300 and divide by 360, that will tell me how many full times it goes around. This one goes 11 full times around, and then another 0.94. If you think about your unit circle, would this make sense that this is halfway around, this is a quarter of the way around, this is 3/4 of the way around? 0.25 is a decimal, 0.5, 0.75. So when I get it goes around 11.94 times, does it make sense that that would end in quadrant 4? 11 full times, and then the last time it's going 94% of the way around, so it's going to end in quadrant 4. Now if I want to find out what that angle actually is, I could take my 4,300. I could subtract 360 11 times. And figure out how many degrees I have left. So I started with this 3960 is 360 degrees times 11 times, because we went 11 full times around. Now sometimes you're not given your calculator. So if I didn't have my calculator, I couldn't do this, right? But I could keep subtracting 360s off of 4,300 until I got to a number that was less than 360. And when I get to 340 degrees, that too would tell me it happens to be in quadrant 4. In radians, we could do the same thing, but generally speaking, all of our questions in radians are without our calculator. So now we have an angle, negative 23 pi over 6. So it's going in the negative direction. And we want to find out what quadrant it ends in and what's the first positive angle coterminal with theta. The method that we're going to use without our calculator is taking the fraction, which is 23 over 6, and changing it to a mixed fraction. Does everybody remember how to do that from grade 8, 9, and 10? Well, you did in grade 11 too. How many full 6s go into 23? There's 3 of them. There'd be 5 left over, so as a mixed fraction, this is 3 and 5/6. And so negative 23 pi over 6 is equal to negative 3 and 5/6 pi. That would be fine as well. Okay? Now in radians, this is 0, right? This is pi over 2, this is 3 pi over 2. And the mixed fraction, the first thing that's going to be helpful is the whole number. The negative 3 means you're going to travel negative 3 pi. How much is it all the way around the circle? 2 pi, right? How much would it be if I went all the way around the circle and went to pi again? Would you agree that pi is coterminal with 3 pi? And then coterminal again with 5 pi. Would you agree that 2 pi is, if you went around twice, coterminal with 4 pi? And if you went around again, 6 pi. So a pattern that we can notice with those coterminal angles on the positive x-axis is they're all even multiples of pi. And all the angles coterminal on the negative x-axis are all odd multiples of pi. So in our question, we want to go negative 3 and 5/6 pi. Well, negative 3 would look like this, starting in standard position. That would be negative 1, halfway around. And then if I got to here, that would be negative 2. And then to here would be negative 3. Does that make sense for the negative 3? And then we need to go an additional 5/6 more. 5/6 is more than half, right? So it will end in quadrant 1. Good? Because it's more than half. 5/6 is more than half. And what is the first positive angle coterminal with negative 23 pi over 6? This is where radians is the easiest. Way easier than degrees. 23 pi over 6, that's a fraction, cannot be reduced. Do you know what family it's in? The pi over 6 family. So when it can't be reduced and it's pi over 6, doesn't matter what the number is on top, it's going to be part of the pi over 6 family. We know in the first time around there's only 4 pi over 6 families. There's pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. If this one ends in quadrant 1, it's going to be coterminal with pi over 6. Okay? And now you can do mental math like, what is sine of negative 23 pi over 6? So you have to think of your pi plate, of your unit circle, and think of the coordinate at pi over 6. What is the y coordinate? It's root 3 over 2 or 1/2. Which one is it? The y coordinate. I'm just, because we're looking, if I want to find sine, if it's 1/2. So now you can do sine of negative 23 pi over 6 in your head. Might be a little bit of time consuming right now, but it'll get faster. First, you'll have to figure out what quadrant it ends in. Negative 23 pi over 6 ends in quadrant 1. Then, after you figured out what quadrant it ends in, then you have to go and say, what's my family member in that quadrant? Oh, it's pi over 6. I know my unit circle, so I can figure everything out from there.